All right, welcome everyone. My name is David Margolin. We're here with another edition of the Subseasonal Forecast Contest. Today is September 1st, first day of September, and we're forecasting out to the 16th and 20th, so it's September 16th to September 20th. Again, we're still in CDDs through the end of September. And we've got a special guest, Professor Roundy is with us again here today to talk about the medium range forecast, and we'll turn it over to Paul in just a little bit. In terms of today's agenda, the suggested agenda would be to start with attribution. We'll look back at the previous week and the season in general, and then we'll fast forward to the forecast. And then if we have time, we can branch off into different research topics and things like that. So before I get going, does anyone have anything else in particular that they want to make sure we cover today? Something about a hurricane, something about some weird weather phenomena, anything like that? Something growing on your foot? No? Okay. All right. All right. So let's start with attribution. So I'm going to go rewind here to our most recent verification, and that was from August 11th. So the forecast from August 11th, verifying just the other day, and it's only fitting that we have Paul on the line because I cheated and looked at this earlier. Professor Roundy had the highest scoring CRPS forecast here. The verification was, God, we have too many forecasts. I'm going to zoom in a little bit so that we can try to get all these forecasts. Sorry, I'm going to zoom in one more. So if you don't have good eyesight, I apologize. So the verification you can see at the bottom was at 57.8 CDDs. So I'll round off pretty close to 58 CDDs. Paul's, Professor Roundy's forecast was 55, but he also had a relatively tight spread, tighter spread than the ECMWF, so you get points for that because, of course, the CRPS skill score incorporates not just the centerline forecast, but also the spread. Paul was relatively confident in his forecast. So Paul had one of the highest scoring forecasts. In general, the forecast, you can see we're very good. This is all relative to the 30-year normal. So some may argue that the 30-year normals, maybe we should use the 10-year normal for the summertime, but right now we're using the 30-year normal, and all the forecasts actually scored better, with the exception, and I feel like a broken record saying this because it seems like this has happened a lot, with the exception of the CFS. The CFS had a forecast near the bottom here of around 40 CDDs, and the 30-year normal was warmer than that, so the CFS was the only non-human forecast to score lower. And I just also want to mention again that we've added these persistence forecasts to our weekly table. So you could see the persistence forecast along with the ECMWF also scored fairly well here, according to our CRPS. And the persistence forecasts have been, especially these longer range, the 30 and 45 day, they're relatively hot because the summer, right? The summer in terms of national CDDs has been, I don't know, the last time I checked, the June, we could check this actually, but the June to August number from Radiant, I think, was number 3 or number 4 since 1950, so warmest. So it's been a very warm or hot summer compared to the long-term average. Let me, and anyone can feel free to jump in here, but normally the process. Yeah,
Dave,
go ahead.
I just have a thought here. So I think we've talked about this probably more times than I can count. But I think if we were to look at the CFS's bias, I think it's something like 11 degrees too cold on average, at least during the cooling season. And if we were to, about 10.6 for the same, basically. So if we were to add that to its CDD prediction, then we would end up with a forecast that isn't too far off. It's I think it'd be around 50 CDs, and the verification was 57, so it would be positive. So I'll just kind of throw out the idea that maybe we should add in a bias-corrected CFS forecast just to show what because honestly it would be more of a real CFS forecast, since it's always consistently off by 10, 11 CDDs. If that makes sense. I think Sean is also doing something along those lines too. Just throw that out there as well.
Yeah, absolutely. I highly recommend. I'm not sure if you were on the call, and I don't have it handy. Otherwise, I'd share it. If someone else wants has it handy, they can pull it up. But we had Nat Johnson on. What was it, 2 or 3 weeks ago? And Nat Johnson from currently who's at Princeton GFDL. He actually put together a small presentation, and he actually looked into that. Right, he did it was a relatively simple, but I thought a very instructive analysis showing what happens if you bias correct the CFS just from the last year or two from our forecast. And it was really eye-opening because it actually showed that compared to some of the other forecasts, it was as good or maybe slightly better. Again, a lot of caveats there, relatively short sample size, and I know I'm paraphrasing some of what he did, but the big picture was it definitely did improve the skill score, and at least for this, for the last year or so, it put it within the ballpark of some of these other forecasts, and it absolutely suggests, two things maybe, more broadly, that there is a important research component there in terms of if you bias correcting that forecast and seeing kind of skill performance, but that you're right, we should incorporate it into our forecast contest. And so, whenever I see something like this, I always two things. One, if we have a student who wants to, has a little bit of extra time and wants to jump on something like this and help us integrate it into the forecast contest, this is an awesome opportunity. Nat's already volunteered all the work he's already done. He'll share everything. In fact, he said we can share the presentation. We already have it on YouTube. And certainly our management team, I guess you could call it here, will try to integrate that into an input, just like what we did with the persistence. But it may take weeks to a couple months before we get there. But I totally agree that it'd be helpful to have that. Any other thoughts on that? Again, if you haven't seen it, we posted it through Twitter, and it's about 2 or 3 weeks old. I highly recommend going to that part where Nat Johnson walked through his research on that.
Yeah, I was there for that.
Okay.
When you mentioned it, I remembered it,
Okay.
but yeah, I think because a lot of people, or at least me anyway, I don't normally think to look at the CFS. I just kind of see the score. I'm like, okay, it's way down there. It doesn't really matter. But if there's a bias corrected version, I might actually look at that and be like, okay, there's a decent range here between the euro and the CFS. When bias corrected, I should say.
Yeah.
Dave, I wouldn't mind doing that.
Okay. Yeah.
I know I brought this up in a different way, though. I think a couple weeks before Nat came on, when I guess you had me question one of the students, and I noticed that there was a lot of weight going on ECMWF and CFS just getting dissed all the time. But it seems over the summer, especially, CFS is more reliable in a way, or consistent, much more so than ECMWF, as something that you can build a methodology off of.
Yeah, no, that's great. So Lynn, maybe you and I can talk a little bit offline in terms of that, because again, this is not just an academic question, right? And Nat shed light on this, right? And Michael's brought up the important question. It could be that it's easy to dismiss the CFS and just say there's no value there, but is that really true? We don't know that yet, right? Because again, just by bias correcting it, all of a sudden, actually maybe it is just as good as some of these other forecasts. Maybe it's slightly better. That's A. But B also is, from a forecaster standpoint, in many cases, you're not just looking at the digital forecast, right? And Professor Roundy will tell you this too. Even the most quantitative, or many quantitative type forecasters, you're looking at the maps too. You're looking at the patterns, right? You're looking for pattern recognition, analogs, and things like that. And it could be that even if the CFS is terrible at the surface, at surface temperatures, that it could be providing helpful information at the jet stream level, right? And so it's important to identify, it's important to investigate that, to as opposed to just, again, dismissing it based on this one data point.
Yeah, and I think you can do a pretty decent investigation into that too using the S2S database. So you can pull these two models back for quite a number of years and get a decent sample size.
Yeah, I think that'd be great. So hopefully, Michael, we can get there sooner than later.
And there's a couple of methods you could use to do the bias correction as well. So,
one thing to think about with the CFS is that it has a breakpoint in the behavior of its reforecast climatology in the late 1990s. And the statistics prior to that time are different from the statistics after it. And so if you can take that into account, it can help you, it gives you a smaller sample, I think, to work with of past forecasts, but you'll get a better understanding of how its biases may actually behave today if you look at signals since 1998.
That's a really good point. And that's still, I always say I'd rather have some data than no data. So, even just, I mean, that's still a very good sample size, and it's more than a lot of people are using. So that's important point. Thanks, Paul.
I've never thought that the CFS was a really great model, but it not only has a long climatology of hindcasts, it has a much higher frequency of forecast initializations than most of the other models, and that's a tremendous advantage because it can fill in a lot of the gap in terms of showing the spread of model behavior and bias in different circumstances than you could get with a sample size much smaller.
That's a really great point too. Again, getting into, if there is a systematic error, you're much more likely to maybe identify it, be able to confidently correct for it with the CFS. And there's, God, we spend the whole hour on this, but it's an interesting topic, right? And one of the things that has come up quite a bit this summer is the fact that some of this is subjective, what I'm saying here, but I think worth more investigation is my point. We've had discussions about the ECMWF. Overall, at least according to the metrics here, the ECMWF has done better, right? And that's consistent with what we've seen. But we've also seen instances where the ECMWF, during those periods where we had some of those hot patterns, but then it transitioned cooler, that it, again, some subjective liberties here, but it seemed like the ECMWF was late to the party in catching those cooler transitions. And that was really important, right? The ECMWF, it just seemed like once it got up to 80 miles an hour, it just stayed there. And there were 2 or 3 times where we saw important, cooler, I'm not saying it was cold, but cooler adjustments this year, I'm sure, for the market. And the ECMWF was just full speed ahead hot. And so my point being that, there could be also conditional situations where maybe the ECMWF does not do that well. And it could be helpful to have those other data points, such as the CFS, in those situations, which may give you value. And again, you don't know this until you investigate further. Okay, this is a good discussion on attribution. Let me just pull up the verification map. This is the August 26th to August 30 period. So this is how it looked from a 2-meter temperature standpoint. So most of the country was warm, anomalously warm, with the exception of New England, up where Paul lives, and points north and east. And then let's take a look at the, let's play Monday morning quarterback a little bit. What was this again? This was August 11th. Let me just pull up the, where's my Maxar? There we go. August 11th. Let's pull up the editor's notes and see what the world, or at least Maxar, was showing. So this is the forecast back then. This is for the verification date. You can see their spatial presentation. You can see the spatial presentation from the EC and CFS. Down here, the Maxar forecast was also pretty good, right? At 54, we know the CFS was not good. This is, by the way, this is something that Philip was mentioning. our CFS number is a little bit different than this number because I think they use a mean of the most of 4 different CFS forecasts, 0, 6, 12, and 18, whereas we take explicitly the 0Z. So that's why sometimes those numbers are a little bit different. But the general flavor was there.
Hey, Dave?
Yeah.
Sorry, could you clarify when you say we and them?
Oh, sorry.
I thought we were pulling Maxar's ECMWF and CFS.
Yeah, so I think what, and it may or may not say here, but I asked them at one point, you'll notice their CFS number is 43. I think what they do is if you go to their model page, they take the mean of the average of the last 4 runs, and that's the number they publish in the editor's notes. In those notes we were just looking, they take why do they do it? I think they've said they do it just, to create, it's their way of creating sort of an ensemble, and maybe to reduce the amount of noise. You could argue it's better, taking away performance, whether they should do it or not, but that's what they do. We, in our forecast contest, our number here is the 0Z. It's only the 0Z. It's not the average of the last.
Okay.
So that is the only difference, I believe, between what our number here and what their number is in the report. So, it's probably a little bit of a longer conversation whether we should conform to them or whether we should keep it the same. But that's why
I don't think it matters. I think either way is fine. We should just note that there. I think for a while now, I thought those were, I wasn't clear on that, but.
No, that's a good point. We should probably
very
maybe in our contest, we could have something like where we put in 0Z or something like that. That would at least help as opposed to just the CFS. That's a good point. That's a good point, something to look at. Okay. So yeah, I don't know. Maybe it's time to get into the forecast. But before we do that, does anyone have any, looking back, any lessons learned, any other thoughts about this forecast period?
I noticed persistence did really well this period.
Let's see. Yeah, that's, let me pull up the super. Yeah, we were talking about this earlier, right? It's been a hot summer, and this was a hot period, right? So, yeah. You can see, and just to gut check this, sanity check this, since we're already looking at this, if we go back to June, if you're wondering, why is persistence so hot? Here's the forecast verification. Unless you live in Arkansas or Oklahoma, you are above normal. And you can see, according to the Maxar numbers, which we use, the Maxar CDD numbers, population weighted, this is going to be the 3rd warmest, or this was, it's over, right? We're in September. So I left off August 31st, but you get the gist. 3rd warmest since 1950. 3rd warmest, and even it's compared to the 10-year, it blew past the 10-year. You can see that up here. So the 30-year was about 870, 10-year about 966, and then this year 1024. So when you're looking at like 30 and 45-day persistence, you're going to be above even the 10-year. So I think I was just doing a kind of quick sanity check on that. But just to fact check that a little bit more. I think the persistence numbers have not done that well overall this summer. Yeah. So when you look at overall this summer, they still tend to be lower near the bottom. You can see there's Paul near the top, and the closest persistence number is what? The highest persistence is maybe the 10-day. So when I think where it took some pain, Philip, was when we had some of those 2-3 week periods where the forecasts were pretty close to normal. I think it took some punishment during those periods. So. All right. All right. I'm going to switch over to the forecast. And once we get to the forecast and once I introduce it, I'm going to turn it over to Paul. But just to give a quick summary of what today's forecast looks like, we've got, again, today's September 1st. We're forecasting 16 to 20. We've got a range from the highest are some of those persistence inputs, which are well above the 10-year at in the mid 40s, as high as the mid 40s in terms of CDDs. The 10-year normal is at 34. The 30-year normal is at just about 27. And the CFS at the bottom, pretty typical, right? The CFS at 17 CDDs. So that's kind of our distribution here. Paul, maybe I could turn it over to you, and if and just to maybe talk about your forecast and talk about any kind of factors or your forecast process, anything that you want to cover that you think is sort of relevant to today's subseasonal forecast. And before I turn it over to you, would you like the screen, or do you want me to share it here?
Yeah, send me this
Okay.
the screen.
All right, over to you.
Okay, let's see. Share screen. Host has disabled. Okay, here we go. Share screen. There we go. And desktop is fine. Okay, so I want to speak kind of in general terms about just how I construct my forecast each week. I'm making my forecasts on Friday. I started doing this way back when I first joined the group because at that time my semester schedule was so much busier on Monday and Tuesday that I decided to try to make my forecast 5 days before the group. And then when my schedule opened up a little bit more, even in the spring and the summer last year, I decided just to stay consistent. Once in a while, of course, this would end up by random chance to my advantage, given that sometimes the models flip to something else. They flip multiple times over the course of a approach of a forecast date. But on average, it should lead to a poorer forecast outcome for me. But I have a basic three-pronged recipe. My first look is to get an understanding of the present background condition. I'll start oftentimes by looking at a monthly sea surface temperature map and then comparing it against the recent weeks just to see how it's trending. And in this case, we're looking at global SST anomaly map over the last month of data. And we're seeing a general pattern of cool across the East Pacific and a horseshoe of warmth out here. It's a pattern that projects fairly well onto a La Nina background condition with a little bit of potential projection from a lower frequency components over the North Pacific. Also, the Indian Ocean, we're noting a gradual change in the sea surface temperature from a warm dominated in the west and cool in the east to the opposite pattern. But oftentimes when we look at these maps like this and focus in the tropics where the contribution of the sea surface temperature pattern to the atmosphere occurs through deep convection, you can't just assume that where it's warm, it's going to be raining and producing upper tropospheric mass divergence and acting as a Rossby wave source. In fact, you need to compare this map against the outgoing long wave radiation or some other metric of rainfall in order to decide how to focus your forecast or anticipate the response. Because especially from the northern spring until around this time of the year, the relationship away from the East Pacific, the relationship between sea surface temperature and rainfall can sometimes be directly reversed from what you might expect. And in this case, you'll note the Western North Pacific has been warm. And we can now go and look at the outgoing long-wave radiation data. I'm using the NOAA Physical Sciences Laboratory. They changed their name again. Go to the outgoing long-wave radiation data there, and this time take a look at the monthly signal, and you'll find that the region of the highest SST anomalies over the Western North Pacific is also a region of suppressed rainfall. This is not a region that's behaving right now as a Rossby wave source. It's not a region of intense convection. It's you might suggest the opposite is occurring, that because there's background rainfall not being achieved, the jet is going to be anomalously weak, and you'll be associated with a Rossby wave response to an anomalous lack of rainfall. And then you're seeing OLR anomalies back here across North Africa and the northwestern Indian Ocean. This region right here doesn't make a particularly strong Rossby wave source. It's not so much a controlling factor as it is a response to a large-scale wave coming this way. So just to understand the perspective, what's going on here, looking forward into the fall and toward the winter, we'd anticipate a reversal of the relationship between sea surface temperature and convection. Going out days, from my perspective, when I was looking forward, days 20 to 25, this is a little bit too far out, I think, to have any confidence that that flip would happen before that time. But once the flip does occur coming into the fall, at some point it will produce a transition in the structure, the favored structures in the extratropical circulation as a result. So then I like to take a look at how models, this is Kyle McCritchie's CFS longitude time representation of outgoing long-wave radiation in the CFS reanalysis or CFS analysis fields and the CFS forecast. This is just an ensemble average of 4 different ensemble members, and you can get a basic picture of a little bit of enhanced convection in some places around the maritime continent, but it's been sporadic, mainly episodic, associated with subseasonal events crossing the region. And so there isn't a particularly strong base state signal that's appearing in here. Most of the stronger anomalies are located off the equator instead of in the 7.5 north to 7.5 south zone. But I look at the alternating eastward moving signals superimposed on it. These are the MJO and convectively coupled Kelvin wave events. You see them coming around the world here. Their structure varies from the ones that project best onto the RMM index. And so I'm going to show you a tool or some tools that I use to track these signals a little bit better to get to better specify them than the RMM index can do in general. So I get an understanding of where the base state is located right now, and then try to project forward where the base state patterns are likely to project onto the mid-latitude flow. Right now, I don't have any useful low-frequency statistical tools for doing that, because the signals are kind of in flux right now between different phases of the forcing signals. And so this time, all I could basically do is try to see where the signals are presently favored, and understand that they're going to seasonally evolve as things progress. So if I go to the 200 millibar eddy heights and get a picture of what the most recent global geopotential height signals are looking like. And I'm not actually using this in my forecast coming up because I don't have a more objective way of projecting this forward into a future state, since my statistical tools right now are not very reliable. And so then I'm putting most of my most of my weight on subseasonal signals. So that's what comes up next. After I've established the base state, I will typically look at simple metrics of the MJO. The RMM index is sometimes really useful in terms of getting a general direction of where the subseasonal signal is going. This index, the RMM index, is not as good at specifying the particular structure of the MJO and how fast or slow it might be moving. And as you can see from this diagram from the European Center climate model, it's basically all over the map at the end of 30 days. And I'm only going out 20, maybe somewhere in here, 20 to 25 days when I make my forecast. So I'm thinking about something that's likely to be moving into phase 6 at that time. But then note how much spread there is. There's a dog slurping in the background. I think you might hear. Sorry. So anyway, the model is large. It has a large amount of dispersion across the range of the map. At the end of this period, there seems to be a bit of movement toward phases 5 and 6 toward the forecast time. And that's kind of what I was looking for when I was putting my original forecast together. I compare against the CFS, looking forward to that forecast period. There's an MJO signal over the Indian Ocean. The CFS has a slow bias with the MJO. It's likely to arrive over the West Pacific a little bit earlier than the CFS would suggest. West Pacific MJO signals have not been very active this year because of the background kind of evolving toward La Nina condition and the suppression of convection over the Western North Pacific in general. So I haven't been anticipating a big West Pacific MJO expression, but there's still a tendency when the when the RMM index gets into those phases to project something offset from what's been going on recently. And so my forecast, I don't even remember what my forecast was when I put this out, but the idea was based on the evolution of the MJO into those into the Pacific ranges at that time. I used this to help me base the seasonal evolution of the MJO signal. Let's see, what's the time frame we're looking at?
You still have plenty of time. 15 minutes?
No. What's the time frame of
I'm sorry. August 16th to the 20th.
Okay, so that's coming back.
I'm sorry, September. Sorry.
Yeah, okay. So it's going to be, I'll choose the 18th in here. You get a picture for how when the MJO signal has convection developing over the Indian Ocean, phase 1, 2, 3. There's a signal that looks something, it favors a ridge near the west coast and a troughing in the middle and ridge to the northeast. When I'm looking for a signal that's moving in this direction, then I want to see, where the models are going in that time frame. And I showed you this one. Now, back at that time, when the forecast was made, we were further back here and then looking forward instead of going all the way into phase 6. But instead of focusing on a particular time, I just want to reference just what to expect in general and then compare that against what some of the model predictions are looking like. So I like to look to the end of week 2 in the ECMWF model and compare that against with where my RMM statistics are going. I tend to weight my forecasts based on the MJO more highly going into the next week when they happen to be in agreement, rough agreement with where the models are going at the same time in terms of the geopotential height patterns. So I would come here and I would look forward, we're looking September 11 to 16, for example. And going back to the Climate Prediction Center and see where ECMWF is at that time. Well, it's all over the map. I think that there's a little bit more of a tendency for it to be toward 5 or maybe inside the circle toward 6 in that time frame. But I think it's more out here and then coming this way. If you look through the more extended model, it's coming out, and then the tendency is to move toward phase 6 later on. So let's see, so looking at this basic pattern, what you want to know is what the next phases, how the next phases flip. And you might even have to move forward in time a little bit to catch the adjustment of the seasonal cycle as they go. So I project forward using the RMM index this way, looking at where the models are projecting the index to land during that time. And then I have a number of statistical tools. This is one that's operational right now. Several of my other tools are broken and need some repair. But this one is based not on the RMM index, but instead on a tracking algorithm that I developed back in 2012, published here in the Quarterly Journal. So this uses a computationally cheap space-time extended EOF analysis, which allows me to break down the signal in different wave number frequency bands. For example, in this case, to target the MJO, but to look at the whole MJO instead of just the part that projects onto the RMM index. In this case, it takes 20 to 30 eigenvectors to specify the structure of the MJO effectively. And then what that means is that I've got a basis of a large number of predictors in order to project now better detail in the outcomes in the extratropical circulation. The cost is that when you use so many predictors, sometimes the quality of the regression models is degraded. Imagine the more predictors you have, you can sometimes get a false sense of skill because you've overfit. In this case, though, I'm working with 40+ years of data and 30 predictors over that time. It does fairly well. So I take the principal components associated with these time-extended EOFs, and then I apply another algorithm, another statistical algorithm that I created a couple of years ago. This is called the method of seasonally varying regression slope coefficients. What this is doing is finding a regression relationship between some predictor index and some field of variables, for example, geopotential height, which is what I'm usually using in most of my statistics. And it diagnoses how the relationship, the linear relationship between that predictor and the field variable changes across the year. And these changes occur continuously, and we would typically maybe take a couple months of data centered on the date you want and train regression models that way. But the way I'm doing it here takes advantage of the whole climatology through all seasons to fit the regression slope coefficients in a way that serves as a continuum instead of trying to arbitrarily choose a part of the year when to fix on. There is still an arbitrary factor in this, though, how many harmonics I use in this seasonal cycle prediction matrix, which I use to fit the seasonal cycle to fit the regression slope coefficients. So once I fit this model, then I can apply it at any time of the year, given initial condition data at any time. And then I can project that forward based on lag regression from today And this is only showing the part of the circulation that's associated with the MJO. And it's giving an expectation value for how that would normally evolve at this time of the year. But it doesn't account for how, say, ENSO might change the expression, or for maybe there's another subseasonal wave occurring somewhere else in the world that's not projecting onto the MJO. Like right now, there may be an equatorial Rossby wave developing in the Central Pacific that doesn't show up on this figure, that may result in different signals. And so whenever you use a tool like this, you want to compare against the maps of the recent subseasonal mean of tropical OLR and geopotential height signals and see how well they agree to begin with. Then I like to compare them against the ECMWF signatures at the end of week 2. That would be this one, looking in the 11 to 15. So we're looking at September 11th to 16th. So I would come into this frame and look at what's different. So you can see in the model that, I think if I go to hourly, you see the change going toward the end of the period. There's, what my statistics are showing is that this western ridge, keep in mind this is 500 millibar and my maps are 200. But going into September, these statistics suggest that this southwestern ridge moves east. And that pattern hasn't been appearing in models yet. But if there was enough agreement early on, when I have higher confidence in the models, then I tend to project higher confidence toward the outcome in here going forward. And so I projected my forecast upcoming to take into account first retreating warm signal in the northeast being replaced by this trough and encroachment of this ridge into the plains region, which would on average tend to increase the temperature outcomes down there. Then I go and compare against the height departures in the ECMWF data. Now keep in mind, I didn't have the Monday data, I only had the Thursday data. But projecting forward into that time frame, you can see a little bit of what I'm talking about. I think the 200 millibar and 500 millibar levels will have the things shifted meridionally from where they appear from each other. But we see this general pattern. I think this trough over here is a risk to impact the northeast. There's potential that this moves off a little faster, but then this signal moves in from the west into this region. That could produce some cool signal here, but warm signals out here. And that's how I created my forecast. I then just compare against the data that you send that Dave sends every week about the 10-year normal and the quartiles and the normal spread. And then I just take those numbers into account based on how the different signals are converging here. Thoughts or questions?
And by the way, Paul, that was great, Paul. And Paul also usually makes his forecast 2 or 3 days before everyone else. So that's just to try to level the playing field. But Paul's still beating everyone for most of the time. But no, that was great, Paul. Any questions for Paul in our last 5 minutes here? I should say too, Paul, I think, correct me if I'm wrong, Paul, but you make most of these tools are publicly available, right? So
yeah, I make them publicly available, but without any kind of owner's manual. So, I mean, I use some of these things when I do consulting with different companies, and I provide advice to them, but the online tools aren't provided with any kind of instruction manual like that. And sometimes that can be frustrating because, well, I can imagine if I had all the millions of dollars available to me that all the modeling centers have, to pay for research and extending these statistical tools that I'm working with, that I would be able to provide some kind of a robust framework of under what conditions they're most applicable and what their biases might be and so forth. But I'm just one guy.
Any questions? I don't think we're gonna have time for other forecasters, but that's fine. So again, any questions for Paul about his tropical forecasting techniques or methods?
Sorry, I was muted. I have one.
Yeah.
I was wondering if you could, maybe it was a little hard for me to pull out because you have such a detailed process, right? And probably the most detailed in comparison to many of our other forecasters. Could you maybe extract from that how your process changes or is refined? Like what would be the biggest difference between your process this week and 4 weeks ago, or are you usually applying the same thing?
I usually apply basically the same steps, but on some occasions I find when my statistical tools are wildly out of range with the models, if I can't project a clear dynamical pathway to get the outcomes that the statistical tools suggest, I reject the statistical tools and go toward climatologies or toward what the models are saying.
Okay.
So in this case, I mentioned one case, one area where I did that for this forecast. That is my statistical tools for the low frequency. If I can show you what this looks like here. I just switch MJO for LP, that stands for low pass. So this is based on the tropical low frequency forcing pattern. And you're seeing some structures emerging in here. First, this is accurate. The Northwest Pacific has suppressed convection. But going forward, it doesn't know what to do with that signal because it doesn't understand. This doesn't include any information about the underlying sea surface temperature.
Mm-hmm.
So, I mean, I could include other predictors that would overcome that point, but I wouldn't use this tool for anything going forward beyond a couple of weeks right now, because of the risk that convection explodes over the Northwest Pacific and Maritime Continent regions. And the IOD is clearly flipping in the sea surface temperature, but not yet in the convection. So I wouldn't use this tool.
Are there any general overall trends as to when your statistical tools tend to not, or you tend to abandon them or would have to?
I think it's difficult because there are so many different possible scenarios. And I don't think I could possibly catalog them all. I think it would be a PhD thesis to really get into that. And I haven't yet found a student who's willing to go through the slog of something that may ultimately result in failure just because noise. There's so much internal variability in the weather on all timescales. And we think that low frequency signals tend to be interconsistent between them, but they aren't. And we have this incredibly low sample size of past events to use. So I I eliminate a particular statistical tool from my palette if it is rendered inconsistent with anything that I trust more.
Mhm.
I wish that I could be more objective about that. I mean, I could use some projection of the present and model forecast anomaly fields onto the statistical fields
Mhm.
and show where they diverge, and then go back in experience when they diverge to determine whether divergence is likely associated with model error or statistical error.
Right. That's, yeah. I think diagnosing that would be very interesting and very helpful to you in terms of, evolving your process or making your decisions faster.
Definitely. Yeah, if I had a team of hands.
Yeah, that's the type of analysis I love to do. But if
I have graduate students, but they're typically interested in particular dynamical problems, and it just seems to be easier to get a PhD
yeah,
when your objective is to understand how systems work, which is my primary research objective, but my primary objective in connecting with industry is prediction.
right. Okay, well, I know we're out of time, but I can maybe continue this discussion another time.
Thank you.
But thank you.
All right. Yeah, I guess that's a good place to leave it. We are out of time. Thank you. Thank you so much, Paul, for returning here again. I think this is great. We'll definitely post this, and hopefully other folks who couldn't make the meeting can watch it later. And hope to see you guys again next week. Thank you, everyone.
See you later.
Thanks.
Thank you.
Bye, guys.